Hey guys, welcome to another video. Today's learning objective is to identify and interpret gradients and intercepts of linear functions graphically and algebraically. Most of this stuff we kind of covered last video, especially in terms of theory, so this video is going to be a bit more kind of worked examples related. So very important if you checked out the last video. As usual, timestamps are here, so feel free to skip to any part of the video. But yeah, let's get into it. Just quick definition, kind of explanation. Linear functions. We talked about functions in a few videos ago, but a linear function, what they're really saying is a straight line. Linear kind of means a straight line, straight effectively, and then function is kind of linear function, just another way of saying straight line. That's kind of a very kind of I think that's a good enough explanation. Hopefully, straight line. At least that's kind of what they mean in this context. And then of course graphically meaning on a graph, and algebraically meaning with algebra. And we talked about what gradients and intercepts were last time around. So let's just get on to the question. What is the gradient and y-intercept for these two lines? So we kind of covered the theory behind this in the last video, so it'd be kind of really good if you kind of pause the video, give this question a go. Okay, so let's start off with the first one. Y is equal to 3x plus 7. Well, let's remember that the equation of our straight line comes in the form of y equals mx plus c. It can come in this form, and remember this is kind of the most useful form that comes in. And when it does come in this form, this m is the gradient, and the c here is the y-intercept. Sorry for the poor handwriting. So if we just look at this, we can say, okay, y equals to 3x plus 7. So here, clearly the m is 3, and the c is 7. So that for question, let's call that A, let's call that B. For A, gradient is equal to 3. Y-intercept is equal to 7. And say, for example, you kind of forgot this terminology about kind of this idea that the equation of the line comes in like this. Is there a way you could figure out what the y-intercept and kind of gradient are? Well, yeah, if you kind of remember the definitions of the gradient and the y-intercept. Y-intercept, remember, is just when kind of the value of y when x is 0. So what you can do is that you can say, to find y-intercept, if you want to show more working perhaps, instead of kind of just skipping to this, which might actually be kind of worthwhile a lot of the time. So y-intercept, you say x equals 0, which means y is 3 times 0 plus 7, which is 7 plus 3, which is 10. So that's the y-intercept. And now for the gradient. Okay, so if you remember, kind of, let's say you kind of completely forgot about how this equation like relates to this. If you kind of remember what I said initially about what a line is and what the equation of a line is, it's the equation of the line. Remember, it's kind of a line being kind of a set of points, and then the equation of a line being true, like the set of points which is the equation which is true for all of those lines on that point. And so, for example, say x equals 1, x equals 2, x equals infinity. Any number of any x is on that line, and all kind of y's are on that line as well. So y equals 1, y equals 2, whatever, they're all on that line. The only question we do have is how those x goes with those y's. And that's what the equation of a straight line describes. So let's go to kind of a graphing thing so we can see that. Okay, so I've got the equation of this line here, right? And as you can see, every single x there is on that line. So x equals 20, there's some value for x equals 20 on that line. And kind of onto infinity, kind of, you can just zoom out, say x equals 800, there's some value for which kind of x equals 800, comma something exists on that line. And same thing for y, and kind of this happens onto infinity. And the equation of a line is just kind of which y's goes with which x's. And to do that, you can just pick an x. You can say if x equals 7, or actually let's pick an easy one. X equals 1, y is equal to, oh sorry, this was a mistake here. 3 times 0 that's just 7. So sorry if you were kind of wondering what that was. So yeah, if x equals 1, y is equal to 3 times 1 plus 7, which is 10. So the point 110 is on that line. And likewise, we can just think of any other number, x equals 2. Remember, all x's are on that line. So we can do kind of x equals 2, so y is equal to 3 times 2 plus 7, which is 6 plus 7, which is 13. So 213 is also on that line. So now if we want to find, say, the gradient, what we can do is, we found 2 points on that line, and we can say gradient is equal to change in y over change in x, which is equal to, say, so we can say this is 2, this is 1. We do 13 minus 10 over 2 minus 1, which is 3 over 1, which is just 3, kind of as we had before. So if for some reason, you kind of forget what the equation of this line, how kind of the form it comes in, and the useful form it comes in, or perhaps you want to show a bit more work in, or kind of say they give it to you another form and you can't rearrange it into this form, so they will get to give it to you in the form of, say, if you had the equation, say, x equals to 3 over 2y plus 7. Well, if you're asked to do this, you might be in a bit of trouble here, and you might not be able to rearrange to this. In that case, you can just plug in a value for y or x, so say x equals 1, so y equals whatever, or y equals 1, x equals whatever. That'd be the easier way of doing it. And then kind of find the gradient, and then same thing with kind of the y-intercept. So just remembering, kind of going back to basics sometimes if you forget these results. That's why it's kind of so important to know these basics. But with B, kind of, we can do this, we'll use kind of the result we've already proved and kind of known for ourselves, and say, gradient for B equals minus 1, 2, 3, and then the y-intercept is equal to 1, 4, 4. Kind of, you can see I got a bit carried away with the numbers, but kind of, it'd be worthwhile if you could kind of use the second approach that I mentioned here about kind of plugging in some numbers and to find out what the gradient y-intercept is. So if you've got a minute, kind of give that a go. Okay, let's move on to, so we've done this kind of, as it said, so algebraically, identify and interpret gradients and intercepts. We've done it algebraically. We need to do it graphically. And so I've got this kind of graph here. And kind of, there's not too much point in doing, I think I'll do 2 of them or 1 of them, and then you can kind of do the other 2 perhaps. It's the same approach every time. And what the approach is, kind of, remember to find the gradient of the line, what we need is kind of 2 points, and then we can do change in y over change in x. So what I do is I look at the, say we're doing B, for example. I find kind of nice points with nice numbers on them, so kind of 3, 0 looks pretty decent. So we can do kind of, so on the side I'll write B, and I'll do 3, 0, I'll write 3, 0, and then let's say, if you look at 4, look, 4 it's between somewhere between 1 and 2, right? Like maybe 1.25, I don't know. And with that, you can kind of misread it. So it's best to kind of look for whole numbers. So if we go to 9, for example, it's 9 and 8. So 9, 8. So the gradient for B, so change in y, so I'll do 2 and 1. Change in y is 8 minus 0, and over 9 minus 3, which is 8 over 6, and then we can divide top and bottom by 2, which is 4 over 3. So that's the gradient. So you can go to this here. Gradient for B is 4 over 3. And okay, so we'll talk about x-intercept in a second. Y-intercept, well, that's easy enough. What we do is we just go to B and see where does it cross the y-axis. It crosses at minus 4, so we write minus 4. And x-intercept, well, we know what the y-intercept is, right? Where the line crosses the y-axis. Well, the x-intercept is kind of just where it crosses the x-axis, which we can say, or i.e. where y is 0. So as you can see on this right here, when the line crosses the x-intercept, y is 0. So what we can do, so we just look at where y is 0, or the x-intercept, you can see where it crosses, and that's just 3. And there we go. If we want to do perhaps another one, just to sort of kind of consolidate, gradient. So which one do you want to do? D. Okay, that looks kind of tricky. Okay, let's do D. So let's look at the nice points. Minus 8, 0 is on there. So I'll write D minus 8, 0, and 0 minus 7 is also on there. And those are actually kind of just our intercepts, right? And kind of with questions like these, they tend to make the intercepts kind of nice whole numbers. So you can always just kind of go to those points. So gradient, so we can do 2 and 1. Okay, so gradient is -7 minus 0 divided by 0 minus -8. That can kind of trip you up sometimes, which is -7 on the top. 0 minus -8. 2 minuses make it positive, so just 8. So gradient is -7 over 8 for D, -7 over 8. And our y-intercept, where x is 0, and that's what y is, so -7. Oh, wrong one. And x-intercept, kind of where y is 0, what's x? -8. -8. And there you go. What would be worthwhile is kind of if you do the other two, kind of just give that a go, see what happens. Let me zoom in. If I zoom in here, hopefully you can kind of pause the video and give the other two a go. Kind of worthwhile doing. And also kind of, so we've covered kind of a few things in this video. This was mainly kind of a recap of last video and kind of an application of the stuff we learned in the last video, especially this y equals mx plus c, which is kind of the general equation of the straight line, which has those useful properties where m is the gradient and c is the y-intercept. But remember, if we kind of ever forget that, we can always go back to basics about how, you know, all the x's are on that line, so we can just plug in a value of x, get a y out, and then kind of do that twice, and we get 2 points. And from those 2 points, we can find the gradient and also the y-intercept, as we kind of talked about last video. So that's always kind of, if you're ever struggling, you can just always feel free to plug in numbers, even just to say, you know, plug in numbers to kind of get a feel for the graph. Maybe you want to, you know, plot it even if you feel like it, if you kind of, that might help you. I know it helped me at times, kind of when I saw an equation with a straight line, I think, I might want to think, oh, what does this kind of look like? So I can plug in, I usually plug in like nice numbers, like, you know, x equals 0, x equals 1, x equals -1 perhaps, kind of x equals 5, those kind of nice whole numbers, which should hopefully give you whole numbers for y, kind of a bit easier to plug in. But yeah, hopefully that all made sense, and I'll see you guys in the next video.